speaker says that. Can everybody hear?
Yeah.
Okay. I don't particularly like the mic that much. But I talk loud. So I'm going to talk about hunting bugs, and in particular a concept called error taxonomies, fancy name for it. But really it's ways to, as a personal tester, you can do this yourself. You can do this in a project that you're working on. But you can even do it in a whole organization. In fact, I've done it for an entire industry, and I'll show you some of that where I've actually turned a taxonomy into a book. Not that that part's important, but taxonomies are really useful. John Hager, Grant Software Testing, how to get a hold of me. I always love emails. So, errors, bugs, they're kind of the thing that we're viewing as an enemy, right? Something we go out and try and find. And yes, you have test requirements and things like that. But a lot of us in this conference have kind of told you, hey, you want to try and find as many of those errors as possible. I would even add, you want to find defects that are important. Okay? And not every defect is the same. So you want to look at the defects that can really affect your system and your user. Well, to do that, you got to know a little bit about your defects and maybe classify them a bit. So, without having some strategies on which ones to go after and the kinds of errors that your system is having or that maybe you're personally testing, you're just kind of randomly maybe shooting at things. Sort of some of the metrics the last speaker was talking about come to mind. So with the taxonomy, it's an ordered way of looking at things. And I'll show you several examples, and we'll talk about how to use them as we go through this. But the key is it helps you organize things, and from there you can organize your testing a little bit better. And I think for people that want to do better testing personally, which by the way, that's how you improve your careers. If you're better at finding important bugs quickly, people are going to recognize you. If your organization wants to find errors more quickly, taxonomy can help them. Organizations stay in business, make money. And as I said, I've even used them to understand how to improve testing in general. So a little agenda, some definitions, research. We'll look at some data and the implications of that data. And then actually look at a couple different ways that I've done taxonomies, from, I'll say, really simple to kind of more complex. And maybe some future work too. Hey, I got a remote. Now I feel in control. Which is an illusion, by the way. So, I like to, I'm a teacher, college teacher, do a lot of this stuff. I always like to define things a little bit. Test is experimentation to provide information. That's how I view testing. And there's lots of kinds of information we may be interested in, all the way from what requirements are we satisfying to what kind of non-functional things are we worried about. One big piece of information are defects. Finding them, making sure they're removed. Several speakers this morning, Dr. Azuma, talked about quality, and I usually call these things qualities. It's important to know about qualities. It's important to make sure we're testing the important qualities. They kind of come in both functional and non-functional varieties. Dr. Azuma did a pretty nice job. One of the ones, again, I care most about is bugs and finding errors so that the software does no harm. If it's a minor bug, a nuisance, maybe I can live with that. But if it crashes the system, that's maybe something you want to go and find. Definition here from Wikipedia about a taxonomy. I'm not going to read the whole thing there. I'll let you kind of read it while I talk. But it's a way of classifying things. Classification becomes important in testing to understand the nature of what we're dealing with and looking at. And too often I find a lot of testers, they use one kind of test technique, one set of approaches, and they use it over and over, sort of like a hammer. And they don't look to see, gee, the errors that I'm missing, maybe, that are getting out into the field, what do those things look like? How should I have found them earlier? If I'm dealing with some qualities as ISO defines them and not testing those properly, and again, maybe some things are getting out into the field, why didn't I do different kinds of tests? Using a taxonomy, looking back at those things, I can start gaining some insight on those kinds of things. And helping to understand and know what to do better. That's really what we're looking for here. So another definition that I think is important, Dr. James Whitaker has a bunch of books out now. Interesting guy. If you ever get a chance to hear him talk, go listen. I will warn you about James Whitaker and James Bach both. They tend to speak that get people upset a little bit. Maybe inspired depending upon your point of view, but certainly they have the unique ability, which I think I lack, to get audiences when they talk at conferences upset, which helps move the industry forward, but confuses people a little bit. I'm going to give you some information here that James says that I think is important. He talks about capabilities of software accepting inputs from its environments. So that's one of the things in testing is we have to define inputs. It produces some kind of output. So that's something oftentimes we're looking at and assessing for success criteria. Often there's internal data. So that's where bugs hide, interestingly enough, is in the internal data of the system. And sometimes testers forget that one. And then usually there's some kind of computation going on being performed. Now from a black box sense, we may miss those on the internal computations, but I'm a big believer that we want to look at all those areas when we're doing our testing and not just be limited. ISO defines a series of quality characteristics. I see Dr. Azula just walked in. His talk this morning was good, setting me up for here because he talked on things in a lot more detail. And I really like the ISO quality thing. So my version of what he was talking about this morning a little bit shows up in here. And this is the basic characteristics out of 25001 down here on this side, and then kind of bug examples that I've seen. This is the beginning of the taxonomy stuff that I'm talking about in this talk. Bad requirements, missed requirements are examples. Missed deadlines over here in performance issues. So I started looking at these kinds of things in my career and saying, gee, how can I better test for those things? Usability. If you have a confused user, probably some kind of issue going on there. Compatibility. Doesn't work from one device going to another. A lot of us are testing mobile devices. Huge number of mobile devices have those kinds of problems. The system crashes. Well, that one's kind of obvious. But you'd be surprised how many systems still get out in the field that cause crash. I have to, it seems like, do something to my smartphone on a fairly regular basis that something's locked up on it. Security, that one scares me. There's bugs in security, it's how the bad guys get in. Maintainability, system's hard to fix, gets expensive. And then portability, it doesn't move from one generation to the next generation like the bug there. So, just some examples. This is the beginnings of the kind of taxonomy I'm talking about here. So, the implications for testing. I like to look at those quality characteristics as a beginning point for defining things like risks and the kind of tests, attacks, and things that I want to do. Helps me figure out what test techniques to apply. My experience is most testers have maybe one or two techniques that they use. If you look at the new ISO standard 29119 on software testing, I think there's somewhere on the order of about 60 or 70 different techniques that get talked about in there. That's a large number. I suspect most of you don't use that many. It also helps you to decide with the taxonomy what level to go test at. What I mean by that, some of the analysis I've done that you'll see coming up here in a bit, is we find an awful lot of errors that developers should be able to find at low-level structural unit kind of testing. That probably means that organization is not doing a good enough job in the developer testing. Other areas we might find things that static analysis would lead. That would lead us to another set of levels and techniques. This addresses techniques as well as methodologies. What I mean by that is a taxonomy can be used in many of the different areas, such things as Agile, which we've heard a little bit about. Earlier there was Mark talking about combinatorial testing. Some taxonomies lead me to combinatorial testing. Model-based testing, risk-based testing, attacks and exploratory approaches, and then just testing on requirements. If you're seeing a lot of errors clustering in the requirements area, yeah, maybe you should do that kind of traditional testing. Taxonomy helps me with these things. So, what do I strongly recommend? At least areas that I've worked, my experience may be different than yours. I like requirements-based testing. Most places I came out at, it was necessary to do that. You had to test the requirements. Now, not everybody has those, so maybe that's not important for you. Did a lot of things with Agile, so stories and scenarios, my next paper. Then risk-based. That led me into understanding taxonomies in a lot more detail, particularly on finding errors, finding bugs. What some people call bug hunts, Elizabeth Hendricks, James Whitaker refers to them as tax. I became very interested in these things in the last few years. And these drive into the risk-based testing. I'll tell you that ISO 29119, the software testing standard, is a highly risk-based testing standard. It emphasizes that a lot. So working with taxonomies would help you implement that kind of standard if you got that standard put on you. Mixing and matching these things really is probably the way to go. What I mean by that is there's no one size fits all here. The it depends rule applies here. How you would structure a test program might look different than my favorite list here, and that's okay. A taxonomy, again, can help you indicate that. So, kind of mentioned taxonomies, a little bit of how to use them, set that up. Very basic definition, but I think it's better to actually see some examples of some taxonomies to give you an understanding of what it is I'm talking about here. So, the one that's up here right at the moment, it goes on for a couple pages. This is a summary level of a very detailed taxonomy I started building, I don't know, 3-4 years back, something like that. And it actually has, it's a spreadsheet-based system. It goes into much more detail, but to summarize it, to get it on some charts, the nice thing about spreadsheets, you can allow things to summarize up. If you went down below these in the actual spreadsheet, each one of these areas had another set of subcategories in the taxonomy, a total of about 64 subcategories. Versus what's in there is about 10, 12, and the next page another 10 or 12. So expansion of about 3 or 4. And then what I was doing is I was looking across some domains of development of products. And as my bio kind of mentioned, one of the areas I've been specializing in is embedded systems and mobile, smartphone kinds of systems. So that's what these categories over here, each one of these columns are. Aerospace, medical systems, general risks. So these were a lot of other kinds of embedded systems that I collapsed down. And then finally some things in the mobile and smartphone area. So my categories over here, super categories, then the domains listed in these other columns. And then what these numbers are percentages. And if there's no number in there, it means it was either a very low percentage or nothing there in some cases. And so if I read some of these examples, time problems, timing problems, performance issues, 3%, 2%, 3%. But you'll see in the mobile smartphone world, at least when I first started this analysis, and this analysis is now a little bit old, there wasn't a lot of performance problems. We started to see these numbers change, by the way. These numbers actually come from a presentation I did at Star West about, almost 2 years ago now. I've been maintaining these numbers. They've started to change. Again, I'm not going to read every one of these super categories over here. Just give you some examples. Time runs. And what we're talking about there is problems that only manifest themselves if you leave the system running for long periods of time. And you'll notice over in the smartphone mobile world, very high percentage. You have to leave the phone on for long periods of time. How I've seen these things is the phones start behaving badly if they're left on for a very long period of time. It could be days, could be even months. We've seen things in the mobile world that fit in this area on long running. So a high number here, okay, 20%. That's an area of the taxonomy that I would probably want to test on that particular kind of device. Areas where there's no number or low numbers, probably not something I want to worry about early on. Now, this data is my data. I'm not saying this data is for everybody, but it's my data for some analysis. I'll get into that in a little bit more. And you'll notice in the domains the numbers are not the same. That says aerospace systems, airplanes, those kinds of things are different than medical systems. Something like computation flow problems, pretty high in medical systems. So if you're testing medical devices, things like pacemakers, by the way, pacemakers now have software in them. That kind of scared me when I found that one out. I probably want to do some more testing in that kind of area in medical systems. The taxonomy went on in more detail. Again, more percentages, higher percentages, things that I want to test. So depending upon the kind of area that I was in, different tests, different attacks is what this is telling me in each one of the areas. And as I also mentioned, I've been maintaining these numbers now for a while. They change over time. These things are not static. So you have to constantly, if you're doing it personally, update your own personal numbers on the testing you're doing, because they're not going to be the same month after month. If it's on a project basis, it's the same thing on a project basis. You probably want to keep these things updated. And you don't have to make this hard. I'll show you some examples of that in a few moments. But you don't just do these taxonomies once. I like to kind of maintain them as time marches on. So that particular set of data, it's probably useful to know kind of where it came from, what I'm doing with it. I read a lot of news reports, articles, websites, conferences like this. I mine data out of those kinds of places. I'm constantly getting things in the web and the forums and emails and things like that. Build things up, go through every few months, update my analysis, and as I said, it changes over time. I've built my own, but I'll look at some more simple taxonomies that you might be able to use, because that spreadsheet that I've got took me a lot of work to set up and maintain. And it's the kind of thing that might not be for everybody. But, key point for you all, it's made me a better tester. Okay? If you're looking for ways to be a personal, better tester, think about taxonomies. I don't see a lot of testers using them, but I think we all want to be better at testing. Same thing for projects. I think projects want to see better testing. Taxonomy can help that. Some implications. What have I done with this thing? It still has a limited sample space early on. Tens of reports, not tens, hundreds of reports. I think I might be pushing upwards of thousands now. It's getting a lot more, I'll say, better data in the terms of sample space. The other presenter, just the last one, had the Mark Twain quote about lies, damn lies, and statistics. I'm very cognizant of the kind of measurement stuff he was talking about in this. So I'm constantly updating and not just relying on one sort of data to keep those things going. The other thing that the taxonomy really shows, that's where those percentages were high, is errors tend to cluster. That's what that's really pointing out. Certain areas, certain domains, the errors occur there, and it's across many companies doing these things. So it isn't just one company or one project, which I found kind of interesting. Will your taxonomy look different, your personal one or your project or even company one? Absolutely. Which is why I say don't just use the stuff that I'm putting here and start basing your testing on that. You've got to do the work yourself. So I recommend people mine their databases. You have error logs, you have error histories. A lot of them are put into tools that you can mine out things and use things. I'll show you some examples, sanitize a little bit of where I've done this kind of thing in the past. Those error databases are kind of a treasure trove that I think you could use better. The information that I've been gathering over the years drove me to different tests. On one project, it drove us to different techniques and tools when we looked at the data, and I'll show you, again, sanitized versions of that. It even changed test plans in some cases. I again want to point out the context matters. You saw I had different domains. You're probably in a different domain, an IT domain. You may be working on a project here in Malaysia that's outsourced or something like that, and that's in yet another domain. Build your own taxonomy. It's going to help you be a better tester on it. And don't look at these things as magic bullets. What I mean there is, I'm showing you some examples, but yours are going to be different. So you can't use this stuff. It's not a magic bullet. But you do the work, you can get some interesting stuff. What I found in the cases of what you were seeing earlier that drove me into some things in the book, errors can be found by developer activities, unit testing, test-driven development, peer reviews, static code analysis. So in the case of my book, compared to James Whitaker's work, I put in things for developer testing. I asked Whitaker about it, and he went, yeah, that's actually something I've realized too. So I extended some of his work from that. Taxonomy indicated some errors in those particular domains that testers should pay attention to. Timing, computational, internal logic, the often what's called integration tests of input-output interfaces going to unique hardware, and problems between the hardware and the software that affected essentially how the hardware behaved. Again, I was dealing with embedded systems in some of these cases. So I did turn these things into a book, and that's where I took this stuff. Not that everybody has to do that, because I think you'd probably use it just locally to do better testing. The other realization I had coming out of this is in the embedded world, and it's changing a little bit in the mobile world, we didn't have good tools. It's better now in the mobile world. The embedded world, tools are still kind of lacking compared to, say, the PC and the information technology world. So, the fact that we're putting software in everything now, particularly in the embedded space and the mobile space, scares me. Why? Because of those errors that are escaping out into the field. Quote here from Lord of the Rings, "Are you frightened? Not nearly frightened enough." I've seen the errors that are hunting us all. They're out there. That's why you can have jobs as testers. It's because that stuff's out there. And by the way, software has killed people. Okay, particularly in the medical device world. You look at some of the big errors, like the Therax problem.